Welcome students. Today's video is on angle relationships. We're going to start with quite a bit of vocabulary review. First term we're going to talk about is parallel lines. Those are two lines that will never intersect, and we learned in MSA as well as intermediate that means that they have the same slope. Our notation is just two parallel bars. So if I wanted to write, for instance, this example of AB and CD, I would say line AB with my line notation is parallel to line CD, again with the proper notation. If I wanted to say that two lines were perpendicular, I would just put this in the place of the parallel signs. Perpendicular lines then are of course two lines that intersect at a right angle, 90 degrees, and their slopes are opposite reciprocal. Skew lines will be two lines that intersect at any angle. An angle is two non-collinear rays that have a common endpoint. So I can see kind of your basic example. Now, notation, you're always going to use the vertex of the angle. You can either name it by the vertex if it doesn't have anything branching off of it. As soon as you start adding more things in, it gets more complex. The most certain way to name it is, of course, by three letters, and you're just going to make sure that the vertex is in the center. So I could name this angle BAC, I could name it angle CAB, or I could name it angle A. Again, when you're naming it angle A, you want to be careful that it's definitely the angle you're talking about, and it can't refer to multiples. An acute angle is an angle with a measure less than 90 degrees. A right angle is a measure of exactly 90 degrees, and an obtuse angle will measure greater than 90 degrees. Congruent angles are two angles that have the same measure. So for your example, it's two angles that both measure 98 degrees. The notation is going to be an equal sign with a little squiggle above. So for instance, if I wanted to say this was angle A and this was angle B, I could see angle A is congruent to angle B. An angle bisector is the ray that divides an angle into two congruent angles. So this guy right here is our bisector. Example 1. In the figure, KJ and KM are opposite rays, and KN bisects angle JKL. So KN is a bisector of JKL. That means that these two sides are congruent. If angle JKN is 8x minus 3, and angle NKL is 6x plus 11, find angle JKN. First thing I'm going to do is recognize that I have two congruent angles, so I can set them equal. That means 6x plus 11 is equal to 8x minus 3. I'll solve this algebraically. So x turns out to be 7. Now I can just plug it back in. 8 times 7 minus 3, that's 56 minus 3, which means angle JKN is equal to 53 degrees. We're going to review a little bit more of angle pair types. Adjacent angles are two angles that share a common vertex or they are next to each other. So for instance, angle 1 and angle 2 in the first picture. Now in the second picture, I could say angle ABD is adjacent to angle DBC. However, I cannot say that angle ABC is adjacent to angle 1 because angle 1 is part of it. A linear pair is two adjacent angles that form a straight line and sum 180 degrees. So the important part is that they are adjacent to form that straight line, and they measure 180. So this one is a non-example because it does not quite make a true line, whereas this is a flat line. Vertical angles are two non-adjacent angles formed by intersecting lines, and they will have equal measures. So if I name this 1, 2, 3, and 4, 1 and 3 will be congruent, and 2 and 4 will be congruent. This right here is a non-example because it's all 4 separate rays. It's not 2 lines intersecting. Complementary angles are two angles with measures that sum to 90 degrees. So I can see that 25 and 65 will work, or angle 1 and 2 are a right angle. Supplementary angles are two angles with measures that sum to 180 degrees. So either angle 3 and 4 or over here with 120 and 60. Notice with complementary and supplementary, they do not have to be adjacent. Example 2. Find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. I'm going to start by drawing my supplementary angles. We're going to say that this one is 6 less than 5 times the measure of the other. So we'll make one of them x and one of them 5x minus 6. Now since I know that they're supplementary, that means that they sum to 180. So 5x minus 6 plus x equals 180. That gives me 6x minus 6 equals 180. So 6x equals 186. And I can figure out x is equal to 31. Now if I plug it back in, I found one side, just need to find the other. So 5 times 31 minus 6 is going to give me the other side of 149 degrees. Example 3, name an angle pair that satisfies the condition. Two angles that form a linear pair. So ultimately I just want to find a line. It really doesn't matter which one you choose. So if I just decided I wanted to work with this street, which goes through P, I, and S, I then just need to break off one more ray so I can separate it into angles. So I'll choose Q. You really could choose anything that you want. So we're going to say that angle P, I, Q and angle Q, I, S form a linear pair. Example 4, find x and y so that the line PR and line SQ are perpendicular. So that means that's 90 and that's 90. So y is easy to solve right away. I can say 4y minus 2 equals 90. Means 4y equals 92. So y equals 23 degrees. Now I'll find my x. If I look, I see that there are two adjacent angles, or complementary angles. So 2x plus 5x plus 6 equals 90. So 7x plus 6 equals 90. 7x equals 84. So x equals 12 degrees. Your homework is 1.4 and 1.5. Make sure that you self-correct and self-track when you are done. The answer key should be in your email. Thanks for watching.